Okay, so let's go ahead and do some more examples where we want to combine everything and simplify it as much as we can. So again, don't forget that we're assuming that the inside is going to be positive, so we have to worry about the absolute values. So same root over here, right? It's the third root. So let's go ahead and write it as a single root. So now that we have this, right, we can change the order of things. So what I'm going to do is I'm going to write it as the third root of 6 times 9. And then the x's themselves, when we multiply, they add the exponents. So this is actually to the 11th because 7 plus 4 is going to be the 11th. Then the y and the y to the 12th add the exponents to give you y to the 13th. Now here, the 6 is really 3 and 2, and the 9 is 3 and 3. So what we have when we pull out when we look for groupings of 3, we can only pull out a single 3 and then the 2 is left over. So we also did in a previous example, remember, we could do it by division. So we have a 3 here, a third root of 2, because that's what's left over. And then we'll do the 11 divided by 3. So 11 divided by 3 is going to be 3 remainder 2. So x to the third, x to the second, because 3 remainder 2. Y 13, 13 divided by 3 is 4, and with remainder 1, because it'll give you 12 and the remainder 1. So y to the fourth, y to the 1, which is the remainder. And then this is going to be your final answer. So let's go ahead and do another one where we have, instead of it being the single x, y's, we're going to have as a polynomial, right, which is x minus 6. So the third root of x minus 6 and the third root of x minus 6 to the 7th, again, can be written as a single radical. But because those are the same, remember, you can add the exponents. It doesn't matter what the base is, whether it's a single variable or not, as long as the base is the same, the rules apply with your exponents. So this is the third root of x minus 6 to the 9th, because 8 plus 1 is going to be the 9. And then again, do the long division. 9 divided by 3 is x minus 6 to the third, no remainder. Now I hope you see that what we were doing in the fractional exponent version, right, explains why you do this division, right? Because you would get x minus 6 to the 9th all to the 1/3, which is x minus 6 to the 9 over 3. So you're dividing by this 3 to get x minus 6 to the 3rd. So that's where this division comes out, why it happens. So let's do that last problem, and this last problem is fairly difficult. We have a multiplication problem, but not everything is in a radical, right? So what I need to do is I'm going to move things around by using the commutative property. So here, this first part can be written out in the front. So minus 5 x squared y cubed z. But since everything is multiplication, I can also bring this part into the front. As a multiplication as well. And then I'm going to put the two radicals in the back. So the square root of 2xyz times the square root of 10xz. So now what we're going to do is we're going to apply that square root, or the putting it under a single radical, to the last two parts, and then we're just going to simplify the front part. So these negative signs cancel. You're left with 5. The x squared and the x to the 4th give you x to the 6. Y gives you y to the 3, and then z gives you z squared. So all I'm doing is adding the exponents. In here, you get a single radical, 2xyz times 10xz, and then go ahead and apply your exponent rules there. So 5x to the 6, y cubed, z to the 3rd, 20x squared, y, z squared. And 20 can be written as 5 times 4, and then 2 times 2. So there's a grouping of 2's there that I can pull out. So what we get is going to be a 2 here. I can also do the division because don't forget there's a square root is going to have a 2. So I can pull out an x as well as a z. So the inside is going to have what's left over, which is this one and that one. Because we dealt with the x and the z, and then part of the 20. Now write the rest out. And then go ahead and finish that off by combining the things on the outside. So this is going to be 10, x to the 7th, y to the 3rd, z to the 4th, square root of 5y. Now that's your final answer. Okay, so one thing to notice is that I actually messed up. The mess up happened from this line down. And what I did was I actually didn't copy it properly. So one of the things that a lot of people mess up on, right, is when you haven't used a certain part of the expression, you need to copy it exactly the way that it was in the previous part. So what I did from this line down to the next one, right, was I evaluated this part to get that part down there. The rest of it I didn't use. So I should have copied 5, x to the 6th, y to the 3rd, z squared, but I wrote it as the z to the 3rd instead of the z squared. So be very careful about what you write. Make sure that when you bring it down that you copy it correctly. So really, this should have been a 2. That also should have been a 2. I'll write it in orange so that we know where the mess up is. And then, when I get a z squared here times a z, this really should have been z to the 3rd. Okay. So be careful, copy things correctly, bring them down right underneath so you can see where you messed up.